Okay, so the first function we're going to look at is a straight line function. And I've drawn a function there already, which is y equals x minus 2. So the minus 2 is your y-intercept. Now, whenever we want to get our y-intercept for a straight line function, we just make x equal 0. So of course, if I make y equals 0, because x is, I make x 0, minus 2, I just get minus 2, which of course would be the y-intercept there. That's why it's minus 2. So y-intercept, we just make x equal 0. Okay, now if I wanted to get the x-intercept,
make y 0.
That's right, yes. And so then I get 0 equals x minus 2. And of course, it always ends up going to the other side, because when 2 goes across, it becomes positive 2. So,
yeah. And that is that to find your points?
Yeah, so that's your x-intercept and your y-intercept in yellow and green.
Okay.
Okay, so now that I've got that, I was able to draw this function fairly easily by just drawing the, just getting the y-intercept and the x-intercept. Now, gradient is the number in front of the x. Now, in this case, I can see that it's 1 because we can't see it, but there's a ghost 1. So like any number, if it doesn't have a number in front of the x, you know that number is just 1. Yeah. Well, we could work backwards to show that the gradient would be 1 by looking at these 2 points. So if you weren't given this equation, but you were given 2 points, you could get the slope of those points by using the y2 minus y1. So y2, we could make it this value, and then so this value then would be y1, this y. And then this 2 here would be our x2, and this would be our x1. So you can do this with any 2 points, and it doesn't matter. You could have made this x1 and y1, and you could have made this x2 and y2. As long as it's 1 and 1 together and 2 and 2 together, because then this equation here works properly. So then it's 0 minus 2 over 2 minus 0. And of course, we get positive 2 over 2, which is 1, which confirms this. Okay, so that's a straight line function. You've got your x and your y intercepts, and you've got your gradient. So now your c is always your y-intercept. If you are given a function which goes through the origin, in other words, it goes through here. So let's say we had a function on a dot. Shouldn't have drawn a freehand, but I'm going to. Now, if this goes through the x-axis, I'm going to make this y equals x now, and on purpose, make these parallel. So if lines are parallel, they have the same gradient. So that's an important thing to note. Lines that are parallel have the same gradient. So we see here, same gradient, same m, right? So the number in front of the x for both of these is a 1. The other thing to note is when you don't get given a c, so do you see, because this gets through the origin, the y-intercept is 0. So there's no like minus 2 or plus 1. It's just, there's nothing there. So technically there is a c, but there's not a c because the c is 0. So this technically is actually just plus 0. Now this would make it very difficult to draw this function, right? So if you were to draw y equals x, and you get your y-intercept, well, your y-intercept when you make x equal to 0 would just be y equals 0.
So, but then doesn't that make it true, because it does run through the origin?
It is true, yeah, perfect. And then to get your x-intercept, you make y equals 0, and of course you get x equals 0, which is true. But the problem is, how would you draw that? Because you don't know. Like if it goes 2x, you'd also get 0 and 0, but you wouldn't know where to draw. So what you do there is to just do a table, and the good old-fashioned table, and to put in values. So you can put in a couple of values here, say 0, -1, 1 for your x. And because x is equal to y, they would both be the same. And then you could actually just plot points. Right? So this would be 0 and 0, 1 and 0, and -1 and 1. And then you could just join the plots, the points up. So using the x and the y-intercept method to draw functions for a straight line is much easier. But if you have a number and it doesn't have a c, then you need just to put a table so that you can get random points on the graph.
So any of the straight line graphs that the line goes through the origin, the graph would be like acceptable in terms of a test.
Yes. Yeah, you could draw it, but it would be important if you had other graphs to make sure that you, or at least name another point on the graph. Because if you only show the intercept over there, it might be good to just name another point.
Yeah.
And if you do have another graph, let's say that this is x minus 2, and let's say they asked you to draw 2x. It's important to know that if y equals 2x is steeper, and so you would need to kind of show that it was steeper by like drawing it steeper. Or if it was a negative slope, so say y equals -x, you'd have to go that way.
Okay, so that negative or that positive will determine which two quadrants the line will run through.
Yes. Yeah. Well, it just determines the slope. With quadrants, we're normally thinking about trig, but I get what you're saying. Yeah. Okay, so I'm going to stop the recording there because that's straight line graphs.